So, I went to High Wycombe this weekend. Didn't do especially well. Could have been worse, I guess, but Louis did quite well. Now, while I was there, I had a pretty interesting conversation with Louis about um, ideas that people have or are aware of, but never really talk about because they don't think it's worth it or they think lots of other people know about it. And one good example of this is EOLR. It was known really, really far back, all the way back to Gilles, and I'm pretty sure Alex and Tom also knew about it. So there's thing now. It's turned out EOLR is really useful, but I'm just going to talk. One of the things that we came up with nowadays that is like EOLR in that it could be very useful. It can be pretty efficient, but no one really talks about is the bars method. So, if we start with just the preliminaries, what we have is, say, a recognition system for 4C. So the bars method, essentially what it starts out as is a recognition method for 4C. So it accomplishes more or less the same thing as BU or DFDB. So instead of, however, thinking what this sticker is, or say, or where DFDB are, what you do is you want to form a few bars. So we see here we can actually make a vertical bar by going U2 M2, and then we've got a bar here and a bar here, and we solve. So it's a pretty easy one. I came across it because I was trying to codify exactly what I did for 4C, but it turns out I do roughly the bars. So here we pair those up and done. Now, what the bars method for LSE is that we can extend it more or less. So essentially what happens is we have a really long set of if else statements, or else if, or whatever. So if we have a certain case, we do this. If we have a certain case, we do this. Now, you can go really, really deep. You can probably write from right from the start of LSE. You can probably even influence it with CML. But personally, my if else tree starts here at the arrow cases, because you almost always have to go through an arrow case to get to 4C. Now what you do is you take note of which edges will pair up after you do a specific set of moves. So say we have here UFUB will pair up. These two will pair up here. Now what we can do is we can manipulate it, such as how I did there, so that we give ourselves a nice 4C case, quote unquote, because it's not strictly a 4C case since we did UFUB. So essentially what you do is from your EO, so for me, for my arrow case, we take note of which edges will pair up. Here I see that after we do orientation, everything pairs up. So what I'm immediately thinking is these two edges will go in nicely. So what we have, we insert them, and then we go U, and then we can cancel into a really nice 4C case. So the power of this idea is that it's not really something you just learn case by case like EOLR. Well, learn, I guess. It's much more like block building. So you just check what cases you might have that are nice. So here I see nothing will actually pair up when I do it. So I'm just going to default to ULUR since that normally gives me the nice case. However, you can manipulate this. So normally I want a yellow center on the top, because then I will get a better 4C case. So, for example. So I'm just going to do a few more examples. It's essentially something you just look into deeper and deeper and deeper. The core idea is you just check what edges will pair up at some point after EO. So here I see everything pairs up. So Since these two are already paired and they go in nicely, I know that I have a nice 4C case. So you can see very deep into LSE, but so you can see pretty far into LSE, and you can also manipulate it so you get nice cases. Oh, here I've got everything pairs up again. So insert. I wanted to keep a yellow center on the bottom, so when I insert, I get a skip. And as a last example, here we have, no, that's a bad example. Everything pairs up again. Yep, okay. So here we only have one set that pairs up. Now this is exactly where I would want to do something like, say, an easy misoriented centers case. Solved. So I have an explanation of why that works in another video, LSE for lazy people. So here, I want to insert these, but here I don't particularly care about the case, so what we do is insert those and we just go straight into 4C. Let me see if I can get a case that's not quite so clear. So, nope. So, let's see what we've got here. Nope. Okay, what about now? Yes. So here we have another case. Now this case is interesting because we essentially do 4B and 4C out of order. So what we do is we essentially create bars before we've inserted ULUR. Now, what I see is that these two edges will pair up and the other ones won't. So you'll always have either one edge pairs up or two edges pair up or 6 edges pair up. So what we do is we solve these two. But since these are now in U, what we can do is we can solve ULUR or UFUB in this case. But we want to keep the yellow center on top and we don't want to affect these two. So it's a 4C case more or less. So we want to keep a yellow center on top and we want ULUR solved. So that, because there we keep the yellow center, insert, and now we get a skip. So as a final case, here these two will pair up, but nothing else will pair up, so we do the same strategy because these are on the bottom. You insert, now we want to force a yellow center here. So, and we get a skip case. So that's how the 4C method works. So that's how essentially the bars method works. So it essentially allows you to cut a couple of moves off by looking at more than just where ULUR are and what sort of bars we can use. So I think it could potentially be more efficient than EOLR. However, you've got all the recognition trades off and things like that, so whether it's faster, I don't know, which is why personally I haven't made a video on it before. It's like with EOLR, things people know but weren't sure could be useful, so I'm just throwing this idea out there because it could be useful. I don't especially know, but it could be. So that's it for today. I will make another video if people want me to, just giving a few more examples. Maybe I'll show you my else if tree. So case after case, all the cases that I think of at all the points where I might manipulate the 4C case and the bars and all of that. So the final thing I want to end with is I'd like to encourage other solvers, preferably those which are even better than me. Well, not preferably, especially those which are faster than me, better than me, been using Roo for longer than me, to make videos about things that they have come across which they don't know if it could be useful, but it might be. Who knows, maybe you could come up with the next EOLR. So that's it for today. I will see you sometime when I get a chance to make another video.